Okay, so last time we did a problem or example 1.3. So after continuing that, we'll be doing problem 1.11. So these are some of the most of the basic questions that you would find in this Griffiths as there in chapter 1, and you should master it. So the question is A. Fx if x, y, z is given as. So you need to just find the gradient of this function. So gradient is f d by dx f. So this is a pretty basic question. Now we will be differentiating the function f with respect to x. So 2x x cap 3y square y cap plus 4z cube z cap. So this is the solution of problem 1.1. So by just applying this, you would be able to do the B and C part of this question. So if you further have any doubt in B and C part, just comment and I'll be also solving those. So continuing that, we have option or question 1.12. The height of a certain hill in feet is given by. Okay, so these are type of questions that you would actually encounter in real life problems, and where you would have a need of solving and using the gradient formulas and the understanding of what is a gradient. So a function is given to you as hxy. So these also have a, b and c part. So the a part just is where is the top of the hill located. Okay, so uh, just understand this as a hill. Instead, uh, think as if hill is a function in 3D, or more specifically we can tell as a curve or a surface in 3D. So to find, so it just applies some basic knowledge which we are very familiar or used it way too many times in 2D. So just in 2D, if you want to find the maximum value of a function, we would just differentiate it and equate it to 0. And the point it would go point where the differentiation would go 0 would be a point of maxima or minima if the function is always differentiable and continuous. So by using that analogy, it is very similar. Actually the gradient of a function is the differentiation of that particular function in 3D. So we'll be finding the gradient or the 3D differentiation, which we can tell of the gradient of h will be, it is a pretty lengthy calculation, still I'll be finding gradient of h. It would be 2y minus 6x minus 18 x cap plus, now for the y1, for the y it would be 2x minus 8y plus 28y cap plus, for the z1 I can't, okay, so there isn't any term for z, so it would be just 0 z cap. Okay, so the point where 2y minus 6x minus 18 would be equals to 0 and 2x minus 8y plus 28 would be equals to 0 would be the point where would be the peak of the hill or the peak of the curve or the surface, we can tell, or the minimum point or the lowest point that surface would hit, we can think of like that. Okay, so equal to 0, you will get one value of y and one value of x, and then just it would be, you would be able to solve. Okay, so the a point just tells where the top of the hill is located. So a is the value of y and x, b is put the value of y and x in the value of h. Okay, so I'll just name y naught x naught, h x naught y naught, and see how steep is the slope in feet per mile at the point 1 mile north and 1 mile east. So south Hadley. In what direction is the slope steepest at that point? Okay, so option C, it's just still easy. It tells you the location from South Hadley, means you need to add 1 mile to north, 1 mile to south, and then put that values in the grad h function. Okay, so just try it yourself, and if you aren't able to solve, again comment and I'll solve it. Then problem 1.13 is also similar to that, so I won't be even solving that, and some of these questions are just for practice and most of them are calculation based, so I recommend you to skip the ones which are just calculation based because they're really easy. You need to just have a good focus on the calculations. Okay, so now after that, question 1.14 problem is also pretty basic and only requires some basic calculations, so I would also skip that. Yeah, problem 1.14 is of transformation of vector yeah, it's of basic rotation, so I would leave this for homework or self work for now, but after when we'll be solving questions related after the topics of spherical coordinate system or cylindrical coordinate system, we will get back here and solve this. Okay, so because it would make just more sense after that.